Hi and welcome to this new video. In this video I continue my Linux privilege escalation series, and in particular we will finish our enumeration section by discussing how to enumerate Linux capabilities. So in this video I will discuss what are capabilities in the Linux operating system, how we can configure them, how we can enumerate them, and then I will show two practical exploitation examples where we give a binary specific capabilities and then we exploit those binaries in order to perform a privilege escalation. And I will show this example within a virtual machine. So this is the virtual machine. So that's it. I hope the video is interesting and enjoyable. If you get something out of it, please leave some feedback, subscribe to the channel, help me grow, spread my channel with like-minded people, and enjoy the video. So to start off, we can discuss what are capabilities in the Linux operating system. What is their role and why were they introduced? Now, other than the basic permissions like file permissions, Linux offers a set of fine-grained permissions that allow processes to do specific tasks with higher privileges, for example, root privileges. Now, I've already discussed Linux permissions, and in that video I said that each file, each resource on the system has an owner, a group, and then permissions for all other users. So like if you get any sort of file, so for example, let's get the file of this presentation, this notes.org. This notes.org has three different sets of permission: the one for the owner, that is Leo, the one for the group, that is also Leo, and then the one for everyone else. In this case, for example, the notes.org can be read by everyone in the system, but can only be modified by the user Leo. So only my account can modify this file. So this kind of permissions apply to every file in the system. And for example, if you have a file that is owned by root, you can specify what the root account can do on that file. Now the idea though is that these permissions are not the only ones. Actually, there are other permissions which are more fine-grained, meaning they do not just handle changes in read, write, and execute. They do not just handle those big permissions, they handle much more fine-grained permission. Now, specifically, while traditional Unix systems distinguish only between two types of processes, those privileged with the effective user ID equal to 0, and I've made a video about that. Go check out the video where I talk about suite exploitation. In the video where I talk about suite exploitation, I talk about effective user ID. I talk about all this kind of stuff with user ID. So when you have a process with effective user ID 0, that process is a privileged process. Otherwise, if it's different from 0, then it is not privileged. It's a pretty simple view of permissions. Now, in Linux, this is not the case, however, because from Linux kernel 2.2, so from this version onwards, and now we are at version 6 point something, I believe, privileges are split into distinct units known as capabilities, which can be enabled or disabled on a per thread attribute. So what does it mean? It means that instead of having like big blocks of privileges like read, write, and execute, now we have much more fine-grained privileges, and you can assign these specific privileges to like files, binaries, programs, and so on. And essentially, they are used to implement the least privilege design principle. For example, a really simple example of this thing is the program ping. Now, the program ping to work in certain distribution, not in all of them, but in certain distribution, the program ping has to have access to row sockets. And this thing is typically something that requires pseudo privileges. So what do? Do you assign to this program the entire permissions of root? Or you split the ability to access row socket into a specific capability, and you assign to this command only the capability to access row sockets. Essentially what happens is that in certain distribution, the ping command has the capability to access row sockets. And now can we see that? Very fast, we can do getcap. We will talk about later on this command, usr bin ping. And notice this, it says user bin ping cap net row equal EP. It means that this binary has this capability with a certain configuration. So it means that it has a capability. Now I said that in certain distributions because this is not true for all possible distribution. There are ways of using ping and of packaging and building ping that does not require having special capabilities. So just bear in mind that sometimes you might not find anything when you do getcap on your serving ping depending on your distribution. The distribution here that I'm using, for example, is Akali. It's Akali rolling 2024-02. So that's the idea. And yeah, so capabilities are used to implement the least privilege design principle, which tells us if you have to do an action, do it with the least amount of privileges required. So if the ping command is to access row socket, perfect. Do not give the entire capabilities to the ping command, but only the one he actually needs. And this is a good principle to have in mind when design system because it makes sure that even in the act of compromise, for example, even if the ping command is compromised, an attacker can only use a limited amount of capabilities and not the entire list. Now, to see the list of all the supported capabilities, you can check out the following links. So here is the main page in the web form, and then there is the Actrix page of Linux capabilities, extremely useful resources. So essentially, this is the capabilities list. For example, we can have caption, make arbitrary changes to file UIDs and GIDs. So like this capability is a specific action. It means that if you have this capability, you can make arbitrary changes to file UIDs and GIDs. If you have capf owner, you can bypass permission checks on operation that normally require the file system ID of the process to match the UID of the file. It's like these capabilities change the way that the system works, and they are extremely useful. For example, cap set UID, make arbitrary manipulation of process UIDs with set UID, set error UID, and so on and so on. It's like they are really useful to know because they can be used, for example, for exploitation. And in the Actrix here, it explains it goes into depth about this, that there are 5 different capability sets: inherited, effective, permitted, bounding, and ambient. And essentially, when you assign a capability, you can assign either in one of these sets, in the inherited, effective, permitted, bounding, and ambient, and they have different purposes and they act differently essentially. For example, if you pass something inherited, this determines the capabilities passed down from the parent process to the child process. It means that if a program has this capability as inherited, when it creates a new child, the new child would also have that capability and all these other details, which for now we're not really interested in. Why? Because at the end of the day, we're interested once again in the system point of view, meaning how do you configure capability, how do you read capability, the enumeration point of view, how do you extract information about the capabilities in a given system, and finally the exploitation point of view. And so the first thing we're interested in is the system point of view. How can we configure capabilities? Now, to obtain all the capabilities of a given binary, you can use the getcap command. For example, you do getcap user bin ping, and here you have the capability assigned to the ping command. Perfect. And this is what we did here in the virtual machine. We did getcap, and this is the capability. Now, to set a new capability instead, you can use the setcap command. For example, we already have the capnet row. Perfect. Let's say though I want to add a new capability, for example, the capnet bind service. How do I add it to the binary? I just do a setcap. Of course, it requires sudo because it requires privileges. I do sudo setcap, and then I put the first capability and then the second capability. I have to repeat this one because otherwise it's just gonna set this only, the capnet bind. So I repeat the capnet row, I add the capnet bind, and then I put the binary name. And with this, we have added the new capability, capnet bind service. I can do it on the virtual machine here just to test. So I can clear this and do this. And then now if I do getcap, user bin ping, notice now that I have 2 capabilities. I have capnet bind service and capnet row. Very useful. And with this we have the new capability, capnet bind service. Finally, to remove a capability, you can also use setcap, but with a minus sign. So here we put EP, which is how we configure the capability, how we put the capability into the various capability sets, so effective and permitted, EP. So this is why it's called EP. And then if we want to remove it, we have to remove it from all the different sets on which we put it. So we do minus EP. So we do this, for example, once again with sudo. And then if I do getcap again, notice that it's gone. So this is really simple. So essentially we can read capabilities, we can set capabilities, and we can remove capabilities using the getcap and the setcap commands. Now, when it comes to the enumeration of capabilities, we can actually use the getcap command, because the getcap command allows for a recursive flag, for a recursive options which searches the entire file system. So a really simple command is the following: getcap-r/ to redirect, this is the redirect for standard error, to dev null. For example, consider this system. So this is the virtual machine. If I do this, what are we gonna get? We have to wait a bit, of course, because it searches the entire file system. And then at the end of the day, when it's done, it's gonna give us all the files with certain capabilities. So notice this. We have ping, as I said, we have dumb pickup, we have fping, then we have d68664 gstreamer, and then we have gdb with a cap sysptrace capability, and then we have Python 3.11 with a cap setuid capability. Very interesting capabilities. So like to enumerate, it's really not a big deal. You can just use this getcap command. Otherwise, you can also get the capabilities of a given process with the command getpcaps. So for example, let's say that I want to check the capabilities of a running process. I do psaux. Here I have a bunch of stuff. Let's get the spice would agent, the capabilities of the spice would agent with PID 861. And I do get pickups, PID, and here I have the cape wake alarm I. So this has been inherited from the parent process. So that's the general idea with respect to the first two methods. Finally, you can also enumerate the capabilities using the pseudofile system /proc. In particular, this pseudofile system, if you go in proc here, /proc, it contains a bunch of different information about the running processes. What we're interested in is, for example, let's try to get this cap wake alarm. So we go into 861, which is all the information for this particular process, for the spice with the agent, and then we say cat status, and we grep for cap. And these essentially are the capabilities we have: capabilities inherited, bound, ambient, effective, and this kind of thing. And to decode this hexadecimal value, it's like a bit mask. To decode it, we can use capsh -- decode equal, here we put the value, and notice what we get here: cap wake alarm, which is the same thing we got previously, cap wake alarm inherited. So the fact that this is inherited, it means that it belongs to the inherited set. It means that it changes this bit mask value, and then we can decode it and obtain the original thing. So we can also enumerate the capabilities of running processes. And so these essentially are three ways in which you can enumerate the capabilities in Linux. Search recursively with getpcap. If you have a specific PID, you can either do getpcaps or catproc PID status. You grep for capabilities and you decode the value using capsh. Now I'm gonna show two specific examples of exploitation, because the idea is that some capabilities allows for privilege escalation. So you just need to learn what are the dangerous capabilities, and if you find a binary with said capabilities, with these given capabilities, then you can exploit it in order to perform a privilege escalation. For example, here I've listed some capabilities that allow you to do privilege escalation, but there is an entire list. You can check it out in the link that I put here in this hacktricks, book.hacktricks.xyz, so go there. So there is this entire list. So the one we're interested in, for example, are Capsh sysadmin, which allows you to do administrative privileged tasks such as mounting device. For example, this capability can be used to do Docker escape. So you are inside a Docker, you want to escape to the host. If you can mount a device, you can just mount the entire file system and you have root privileges over the entire file system, which is pretty dangerous. Capsh ptrace, which allows you to debug any process using the ptrace system call, so ptrace, and we will see an exploitation of this, very interesting. Capsh module, which allows you to load and unload Linux kernel modules, because the Linux kernel, since it's open source, has been developed with a technology known as LKM, which stands for Loadable Kernel Modules. And this LKM technology allows drivers, for example, to install specific module when you plug in a USB device, for a practical example. So the idea is that when you load modules into the kernel, you're actually increasing the kernel code. And if this kernel code is malicious, it could be a really huge problem. For example, a lot of rootkits start off by being kernel modules, which then hide and modify data structure within the kernel. So very, very dangerous capability. And finally, the capsetUID, which allows to set the effective user ID of the created process. Once again, really dangerous. You can just set it to 0 and become root. But as I said, this is just a limited list. A more extensive one is the following one. So this list, for each of these capabilities, they allow you to do something interesting which could be damaging in terms of security. Now for our practical example, I will show just two to give the idea. One is going to be with capsetUID and the other is going to be with capsh ptrace. So let's start with capsetUID. Because if you remember well, after we have enumerated all the capabilities in the system, we can do it again essentially. So it's like getcaps, getcap, r/, and then we redirect the standard error to dev null. So after we do this, we notice that we have a bunch of interesting capabilities. In particular, we have the capsetUID on Python 3.11. Now, why is this dangerous? And we can just zoom in by saying getcap of this binary, and we get the capsetUID. Now, this can be easily exploited as follows. So, consider this folder. Here we have Python. We have actually, I think it's py. It's capsetUID py. So, notice this simple script. We import two Python libraries. These are internal built-in, so we don't need to download anything. And then we do os.setUID to 0, and then we spawn a bash. Now, this thing normally wouldn't really work because we could not do this. We could not set the setUID to an arbitrary value. However, since we have the capability, since the Python 3 interpreter has the capability to make arbitrary changes to the effective user ID, we can literally just set our user ID to 0. And when we create a shell, when we create a bash shell with this, notice this. So I start with the user Leo. I'm UID 1000, and then I say cap setUID. And notice now, who am I? Well, I am the user root. So it worked. It's extremely easy. Why did this work? Because if I do getcap of usr bin Python 3.11, this has the capsetUID. If I remove this capability, so if I do setcap capsetUID minus of Python 3 like this, now it no longer has this capability. What I can do is I can try it again, capsetUID, but of course it's not allowed because this operation, the operation of arbitrarily change the setUID, is not allowed. It is only allowed because before this binary had this specific capability. So here I'm gonna set it to plus, and then if I do it now, it's gonna work again. So anytime you see capsetUID capability, you can probably most likely exploit it. Of course, it's not always this simple. You still have to force the program to make a setUID system call. But in this case, it was Python that had this capability, and we can write arbitrary code in Python. So we can also do OS setuid. Internally, it is developed to translate this instruction into the system call to change the user ID, and then we can just spawn a bin bash. So really simple exploitation. So this is the first example. And so our first example we have completed, which was this one, Python 3 with a cap setuid. Now the next example has to do with GDB, which has the cap sys ptrace capability. Now I've already made a video on the tool GDB. It's essentially a debugger. It allows you to debug program, and I've made a video showing how you can get started with GDB. So go check that out. I'm not sure if it's out yet, but if it is, go check that out if you're interested. Now, in terms of the cap sys ptrace capability, this capability essentially has to do with ptrace, with the usage of the ptrace syscall. Now, what is ptrace? Ptrace is the foundational of all debugging because it allows a process to have control over another process. For example, it allows a process to say to the system, look, when this other process gets into this state, then stop its execution. And this is all done through the ptrace system call. It also allows to modify the memory of other processes and so on and so forth. So this thing is mainly developed for debugging reason, but of course, what one sees as debugging reasons, another can see as a means for privilege escalation. So essentially that's the idea. Now, why is this dangerous? Well, because if we can just arbitrarily modify the memory and the execution of a program, then it's like really simple to understand that this can probably be used to do privilege escalation. So how can we do it? Now, there are many ways in which we can use this, but they all revolve around the same idea. So the idea is that we get a process that is actually running on the system as root, and we can do that with the command psaux and then we grep for root. For example, in this case, we have the system journal, whatever. Then with GDB, we can hook into a currently executing program, GDB with the -p flag, and here we put the PID. And notice that now we are debugging that particular root process. I mean, for some opening of files, it says permission denied, but essentially we do have control over the process. So that's the idea of the exploit. Now we can exit because we don't really care about that. So there are many ways to exploit this. I will show a very simple way that has to do with using Python. So let's say, for example, we have a Python root script that has this simple code. So I'm not really interested about the code. I'm just interested about a root process that is executing a Python script. For example, Python root. So here I just started the process as root. Once again, I don't care about the logic, the internal logic. It could be any sort of logic. What I'm interested in is that it is a root process and it executes Python. And I can notice here that if I grep for root, the last process is Python 3 python root.py with the PID 1426. Now at this point, we can do what I did before, but with 1426. And now we are entering into essentially the process. Perfect. And then we can just do a call system touch tmp test. So we can just do a call of system, and then we can put our like the command we want to execute. If we do this, this is gonna there's gonna be some permission denied for sure, but the idea is that it's gonna execute this command as root. And indeed, if you go into the tmp folder, now we see a file test that was created. Not only that, this file test has been created as the root user. So very, very interesting. And so, for example, we can just do a call system of any reverse shell payload, and here we get a connection running as root. So we can get a full shell running as root. And this all has to do with the fact that since the GDB command has the ptrace permission capability, then it can hook into any process, even those that run as root. Because let's getcap user bin GDB. So let's do setcap. We're gonna remove this. We're gonna do setcap minus user bin GDB. So task for a password. Okay, we have removed the capability now, there's no more capabilities. And now if we try to hook into this root process, it's gonna say, look, ptrace, operation not permitted. We are not able to attach to process 1426. We were only able to attach to the process because we had this particular capability. And now we do it again. And now we are able, and we get, for example, if I get the TUI, I mean, here we do not have a source, TUI layout ASM, and we attach to the root running process essentially. But this only works when we have the ptrace capability. There are other ways of exploiting this. For example, another way is to inject our own shellcode and try execution like that. It is not always that reliable. This method for Python is pretty reliable, but of course it requires Python to be running, but there are many ways essentially to get code execution as root even without this specific setup. And it's up to you to explore, because there's a lot of stuff in this space. And so this is it for this video. I discussed what are capabilities in Linux, how we can configure them, how we can enumerate them, and finally I showed 2 specific exploitations example. I will leave some references in the description. This has to do with main pages, of list of capabilities and specific tools, a Stack Overflow command which was useful, and the page on hack tricks. So go check out those references because they are extremely useful. In this space there is a lot to say. This is just to give you the basic idea with some practical exploitation example. You will find all the material in the GitHub page. So as always, I hope it was interesting and useful. If it was so, please leave some feedback, subscribe to the channel, and share this video with like-minded people. Thank you for the support, and to the next video.